More about ions. If you go to table 4.4, it looks like this. But I'll give you an example here. I'm also going to do, well, first of all, look at this chart. Look at table 4.4. Notice that almost all the polyatomic ions are 1 negative, almost all. C2H3O2, I'll tell you what these are, a little more about them in a second. That's negative, CO3 is negative, that's called carbonate. CHO3, negative, hydrogen carbonate, etc. NO2 and NO3 both exist. One is called nitrite, one is called nitrate. We have sulfate and sulfite over on the right. Dichromate. There's a couple of them that are 2 negative. The one that's 3 negative, they didn't put on there. So this is phosphate is 3 negative. Also notice only one of them in this chart is positive. So let me show you a little bit about what these are. These are actually covalent compounds. It's just you can't have a covalent compound and have all the atoms connected up. And if you added up all the protons that are there and all the electrons that are there, there's an imbalance. We'll get to covalent bonding later. But if I drew this as a molecule, I would draw carbon connected to a carbon. I guess we lost the good marker. There's a double bond to an oxygen and another oxygen. This whole thing overall has 1 extra electron in it. We do like that when we're doing the chart. So this is what we call a molecule. Covalent compounds we call molecules. But we haven't gotten to these yet. I'm going to stick with ionic compounds for a while. But just to show you what a polyatomic ion actually is, it's a covalent compound that we haven't studied yet. It just so happens that it's charged and it has its own name. I'll give you another one that's on that chart. There's 2 other positive ones, but you won't really deal with these until you do acid base in 1212. H plus and H3O plus, those are closely related to acid-base phenomena. So really, I guess that's the only one you would have to deal with in this chapter, in this class. This is called, this would say, formula would look like that, NH4 with a plus on it. This formula has C2H3O2 with a negative on it. This is an actual diagram of this molecule. This is the formula for the molecule. Similar to the ionic formulas we were doing, but it's a molecular formula. So dealing with these, sorry, did I erase that too fast? Did I?
Okay. You don't have to rewrite it.
Let me rewrite it. Find it good. And let me add this. I shouldn't have erased it because I wanted to do this. So they have a name and a formula. We'll get around to doing covalent structures like this. So going back here, is just below table 4.4. It gives you, there is a little bit of systematic naming going on here. Let's do, rate those. I guess. Write these on the board. First, let's do this. So there is such thing as C2, H3, O2, negative. Na is a +1. This whole thing is a -1. That's an ionic compound. These are a little frustrating because getting familiar with these and then having them jump out at you so you can name it, you find that a little bit difficult, but this is sodium acetate. These polyatomic ions only have one charge, so you don't need a parentheses with a Roman numeral in it. And there's also such thing as, we would do this. We put it in parentheses and then put a 2 there. Because it's -1, and magnesium is +2, so we need 2 of these. See what I mean?
Yes.
And let's do NH4. So this is a +1 ion, this is a +1 ion, so you have this. +2 ion, you have to have 2 of these, so you can have a parentheses with a 2 of them. This is a 3 negative, and this is, there's 3 of these, so there's 3 +1 charges. So you put parentheses and put a 3 there. This is, and I'll remind you, there's no di, tri, tetra, penta involved in any of this ionic stuff. So you can name them. Question?
Are we going to have a polyatomic ion list on the test?
Yes, I'll give you these. I'll give you literally that chart. You don't have to memorize it. You guys ready? I want to show you some patterns. There is all of these exist. Almost all the polyatomic ions involve oxygen. It just has unique properties that does this. It'll make it can bond into a molecule very easily, and yet have an extra electron in the formula, in the structure. This is I think I did that backwards. Perchlorate, I did do it backwards. And I just want to point out, there's 4 of them that you can learn. Like I said, I'll give you the chart. But you have the halides, the second from the left, column 17. You have fluorine that doesn't do this. You also have chlorine, bromine, iodine, and I think that's it. But I can replace chlorine and the chlor in all of these, and then everything's the same. You would put brome, there's such thing as this, and I don't think all of these are in the list, so you have to learn how to do this. If I just replace the Cl with Br and the chlor, so you've got hypobromite, bromite, bromate, and perbromate. Perbromate? Why do I keep thinking this is wrong? Perchlorite. I did it right. Is that what that says? Hypochlorite, chlorite, chlorate, perchlorate. I don't know why I keep thinking it's wrong. But they're explaining that here about halides. There's also a pattern with a couple of others. I'm going to erase this now. So all of the halides can follow that formula for the naming. And notice that so you still use 8 and Ike here. Those are in this chart. Nitrate, and even though you change the number of oxygens in there, it's still the same charge. Even though they change the number of oxygens here, it's still the same charge. So there is some pattern. What other patterns? Okay, I'll show you. Okay. Sorry, did I erase that too quick?
No.
Stop me if I'm about to erase it. Just stop me. Just go, hey, wait. I mentioned this, and this is known as a mild acid. So if you got a molecule where an H plus will pop off, that's an acid, but we won't go into it. This is considered an acid. So there's this ion, and there's this positive ion. If these come together, you neutralize one of these charges, and you get 2 plus. Sorry, these are negative. That's phosphate in that list. Hydrogen phosphate. And then if another one of these comes in and pops on, you would have H2PO4, 1 negative, and it's now di. After all my big speech about no di, tri, or tetra, this is the one weird case where the word dye shows up. You can add another H plus, but now it's not even charged, it's not an ion, HPO4. And you would think that's triphosphate, but that's actually, this is what she was asking her, am I gonna talk about acid? That's phosphoric acid, but don't worry about that. I just wanted to show you that progression. These are all in that chart too. Okay, camera. Kind of at a loss as to where to go now. I think the next thing I would have done in the previous book I used was show you some simple reactions. I'm sorry, they don't do these. All the way to chapter 7. That's crazy. Y'all need a list of the sections I'm jumping out to as well.
I would rather for all of us.
Show me a reaction.
Make fried pickles. With what stove? What? I said with what stove?
I suppose I'll just do solubility of ionic compounds. I've jumped all the way up to chapter 8. Table 8.1. Solubility means will it dissolve in water? Table 8.1, this is the guy who tells you what's soluble in water and what it's not, if it's an ionic compound. Many ionic compounds will dissolve in water. One that you're familiar with is NaCl. I know I don't have the camera on. Put the camera back in a second. NaCl is table salt. You probably already know if you put a little salt in water, it just dissolves. You can't see it. And that's what we mean. If you take a, I'll come back to the chart. But if you take some ionic compounds and you put them in water, they'll fall in the water and they'll just kind of disappear. What's going on is the water molecules pull these apart. You get the actual ions themselves floating around in the water. So when you dissolve table salt in water, that's what's happening. The sodium and the chlorine separate, and they're just floating around, and the H2O molecules separate. Some ionic compounds, if you put it in water, it won't dissolve, and you won't see it disappear, and usually it just kind of floats down to the bottom. This chart tells you what's soluble and what's not. I'll give you this little piece. If if something is dissolved in water, we put a little parentheses here. It's an AQ, it means aqueous. The S here means solid. So if you get some salt out of your salt shaker, it's still solid, it's little grains. And then you put it in water, and it becomes this. So it's that in the salt shaker, and it's that when it's in water. So there's a set of rules you can follow. The reasoning is, I think, beyond this class, why some dissolve and some don't. It might be in this book. But the way you use this chart, look at table 8.1 and look at the first section on the top left. It's compounds containing these ions are generally soluble. But sometimes there are exceptions. So you see on the left, the first line has positive ions, and it says there are no exceptions. That means if you see lithium anything, it dissolves in water. Any lithium ionic compound dissolves in water. You follow me? Any ammonium compound dissolves in water. Any potassium and any sodium. That's what that's telling us. Nitrate and acetate also. It seems like there are exceptions to nitrate. I don't see exception, but we'll go by this chart. Okay, and you see Cl, Br, and iodine. Those are the halides. And there are exceptions. What this is saying is, if you have, let's see, we'll do silver and lead. Ag is silver. Lead. Better look. Lead, when it's an ion, is 2+. That's a transition metal. So is silver. Those are the charges on these. What I'm saying is, put any of those NaCl, NgCl, what else should I do? Beryllium, Cl2, Al2O3, oxide. Those will all dissolve in water because they don't show up in the exceptions. Sodium, magnesium, beryllium, and aluminum. Here's the exceptions, and they don't show up here. So in the exceptions, it's telling you anything Cl, Br, or I is in will dissolve except for these. The things that won't dissolve in water are these. For example, silver chloride, lead chloride. Won't dissolve. Will dissolve. That's how you use this chart. Chart. If I minimize the camera down to the bar, it does shut off when I do that, so that's why I'm careful to do it that way. Exceptions to sulfate, and notice a lot of the exceptions are the same. Lead is in both of these, silver Ag is in both of these. Okay, and down here, the bottom left of 8.1 is saying these are the compounds that are never soluble, except, and then the exceptions are on the right. So, write some of the figures. bottom of the chart is telling you
There's gas. Oh, we can.
here's something that will not dissolve. The ions on the right, they're telling you won't dissolve. It's that one. There's another one. I'll just do a couple of examples. Exceptions. The exceptions for these. Li plus, Na plus, A plus. And then for the CO3, the exceptions are all right, so if I came up with examples, here's what won't dissolve. That will not dissolve because calcium is not in the exceptions. So we're kind of doing this the opposite way. We're stating what will not dissolve, but the exceptions are the things that will dissolve. What else can I do? So OH is a polyatomic ion. Pretty sure it was in that list. That was in that list for sure. Carbonate. So Mg and Ca are not in the exceptions list. So they will dissolve. I did that wrong. This 2 should have been down here. No, I didn't do that. These will not dissolve. And these are the exceptions.
Are they gonna be given the chart for the test?
Yeah. Yeah, I'll give them that chart. Let me come back to this. And let's just look for some problems to go through based on the ionic stuff. I knew I'd struggle to fill up class today, so let's just do some examples. I guess I could tell you that, remember I mentioned my dad was in the hospital? Didn't I say that last time? So he's still there, he's gonna have to have back surgery. So I've been up late the last few nights and I haven't had time to do anything. But I think everything's okay, he's just gonna have to have surgery. As long as the surgery goes okay, he's really not all that mobile to begin with, but when you're that elderly and you lay up for a couple of weeks or how long it takes, he might have to go back to physical therapy to be able to move around again. So that's probably really the big downside here. So I haven't had much sleep in the last few days, but at least now we know what happened and what's going to happen. So I'm quite prepared for a class this long today. But let's go through some of these ion examples. If I can find some good ones. Okay. I generally ask these types of questions. Y'all get the odd answers, so let's go through number 30. So this is number 30 under exercises at the end of the chapter. And I'll write these on the board. Yeah, just let me come back to solubility, because if I don't think about it ahead of time, I start bouncing around like I'm doing now and can't get anywhere. Okay, here's the question. Okay, so the question is CO2 ionic or covalent compound? Would you say? Yeah. Can everybody see?
Yes.
Why is it covalent? Don't just guess. You need to know why. Why is that covalent? So why is it covalent? It is covalent. It's covalent because carbon and oxygen are both nonmetals. It's that simple. Ionic or covalent? This one's ionic because you have nonmetal and a metal. So that's ionic. This one? Metal, non-metal, so it's ionic. ECl3, covalent. Phosphorus and chlorine are both non-metals. The ionic ones, what's the name of this? So Na stands for sodium. And you just write that off the periodic table. But instead of putting iodine, you put iodide. I'd like to capitalize this letter for emphasis, but I think proper usage is lowercase. This one, it's going to be an Ni is nickel. But we have to do this. What's the charge on the nickel? It's 2. Chlorine has a charge of -1, and there's 2 of them, so there's 2 negative charges. You need 2 positive charges to counteract it, and there's only 1 nickel there. So that has to be nickel 2. That's nickel 2 chloride. So you could do 29, it's just like this. No, I did 29, whoops. Okay, I'll go ahead and do 30 now. CF2, CL2. Y'all read those to me. What's the next one? What's the next one? CCl4. This one. Can't hear you. ETO2. SO3. There is such thing as but there's also a neutral form. So the lack of a charge here tells you that's not a polyatomic ion. Just to clarify, that's in that list of polyatomic ions, but this is not an ion. Okay, the first one, covalent or ionic? Did you say ionic? Covalent, just look at your periodic table. Carbon, fluorine, and chlorine are all on the top right. This one? It's not platinum dioxide, it's platinum oxide. What's the charge on platinum? Oxygen is -2. There's two of us, 4. There's only one of those, so do the Roman numeral 4. Questions like those you can review. They do covalent and ionic in the same chapter. Okay, I'm gonna make sure I don't do, so 49 and 50 are good practice. I won't do 49. Silver is Ag. Sodium, aluminum, potassium. Skip the silver one. There's 3 exceptions periodic table to variable charge, and they happen to be these 3: zinc, cadmium, and Ag right here. I just didn't mention it. But let's skip the one on silver. It's -1. But we tried to use sodium and sulfur. Might have done this one as an example. What's the ionic formula there? First thing you do, what's the charges on these? What's the charge on sodium? What's the charge on sodium? What's the charge on sulfur? So the formula will be Na2. And what's its name? Sodium sulfide. Sulfur becomes sulfide. You want to do more of these? Let's do aluminum and sulfur. Sulfur is 2 minus. What is aluminum? It's 3. It's the only one that's 3 plus that's predictable. You can come up with other 3 pluses elsewhere, but those are on polyatomic ions. It's predictable. But it's the transition metals. You can have 3 plus and higher. So what's the formula?
Al2, that's aluminum 2. Sulfide.
It's sort of like you're doing that. So, but I consider that sort of a mnemonic that doesn't explain anything. Okay, here's some names. I didn't have the camera up. They give you the odd ones. I'm going to do the even ones here. never used the periodic table before, it's good to practice finding things on the periodic table, since they don't make you memorize names and symbols, but you still have to hunt around on the periodic table. So when you're practicing these, just kind of familiarize yourself a little bit. I think if you learn the first 2 rows, maybe the first 3, hydrogen and helium, and then the next 2 rows down, it helps a lot, because then you know when you need to start looking for more exotic stuff somewhere else on the periodic table. But this is 10, SN is 10, PB is lead, Fe is iron, Cu is copper, Hg is mercury, Cr is chromium. So you know you need at least that much to name these. So what do I got to do next? Cl, 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 Cl. These are all -1, so I have -4. These are +4. I only have 1 SN, so it all goes to that. So it's 10, 4. Chloride. Lead. 2. So I have I negative. So I have -2. That means I need a +2. I've only got 1 up here, so it all goes on there. This is lead. FeO3 we already did, but let's do it again. Oxygen, 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 2 minus, 2 minus, 2 minus. So it's -6, +6. I've got 2 Fe's. I've got to split that among them, so it's going to be 3 and 3. So this is iron 3. Oxide. What else we got? Cu. I is 1 negative. That means this has to be copper 1. Iodine. Mercury. Bromine is -1. So that means this 1 hydrogen that's here, that's Hg. Handwriting made that look like a 9. Hg. So that's going to be mercury 1. Cl is 1 negative, and there's only 1 Cr here. So there's 2 negative charges, so the Cr has to be 2 plus. So this is camera. Any of you watching on the camera? There's the formula, there's the names. Keep reminding me about the camera. Let's do, okay. Number 58 in the exercises. And 60. Bring the camera back. Here's a few more. Okay, let's name these. You probably recognize that polyatomic ions are here. So you want that chart. And the chart has the charges in it, but you really don't need to look at the chart for the charges. You might want to look at it for the name. But what do you think the charge on the OH ion is? Given that there's two of these and only one Ba,
+1.
right? If you look on the periodic table, the top left, you'll see Ba and you'll see that it's a 2+ charge. And since there's two of those, that means you have Ba 2+ and OH negative. You've got two of these, and that gives you the two charges. You would go, Ba is barium, and the OH is called so if you look in that table, you'll see that OH is called hydroxide. All right, do you remember what this is called? That one is ammonium. And that's iodine. So this will be you don't need parentheses with polyatomic ions. Do you remember what this is? Hypobromite is the one that only has one oxygen. Bromite has two oxygens, and they're all just negative. Then you go to bromate. Perbromate. So they're all -1, but see the pattern. It's one bromine on each one. There's one oxygen here, 2, 3, 4, and you've got that pattern. What's in that chart is when there's Cl, when it was hypochlorite, chlorite, chlorate, and perchlorate. Bromate isn't in that chart, so that's why I showed you this. So this would be, it's the O4, so it's perbromate, so it's sodium perbromate. This is Fe is iron. This is hydroxide, so this is iron hydroxide. Did you say shouldn't it be higher? I think I wrote that down. Fe, yeah. Sorry, this was OH, 3. Oh, yeah. We do need the parentheses here. I literally just said you never need the parentheses. Iron. Yeah, you do need the parentheses sometimes. Yeah, when the positive ion is a transition metal, you do need it. Whenever it's a transition metal, you do need it. This is 3 makes this. That's ammonium chlorate. That's 2 M's. So that's in that chart. The chlorate is in the chart. CO is cobalt. That's zinc. SN is 10. What do you think the charge is on cobalt? Do you all see that? F is near the top right of the periodic table. If you count to the right, you count to 1, so it's -1. And And there's 3 of them, so cobalt has to be 3. There's only 1 cobalt, so it has to be 3. Zinc. If you bring up the periodic table, those that I said are exceptions. Chemistry is always, here's the rule and here's the exception. In fact, a lot of things, we give you all as rules. Undergraduate, you find out that you can actually break those rules later. The fundamentals, we have to show some of the exceptions. But those on the left side of the transition metals in this L shape, those are exceptions. Those always only have 1 charge. I forgot what cadmium is. Cadmium is, I think it's 2. But silver and zinc, I think are both 1. I won't write down cadmium, but I think it's 2. Just don't remember. I'll look it up just to be complete. Zinc is, cadmium is, I predict +2. Yes. These are the exceptions. These always only have 1 charge, so they're the only exceptions to the transition metals being variable. And I bring that up because sometimes you'll see them drop off that parentheses for these. And they only do it because they're predictable and there's no reason to put it there. But when I explain this, I usually gloss over that until the end. Okay, so what's the charge on this? Or what's that called? This is chromate, right? And we'll have to go all the way back up. Remember what table that was? Just want to be sure that it's chromium. Yeah, CrO4 is chromium. Good. So this is zinc. And I'm tempted to do that. But like I said, zinc is an exception, so you'll frequently see that not written there. Because zinc is always +1. What is this one? Periodic table again. These are weird, the ones in that lower triangle. So let me skip that one. I guess I think 10 is 2. No, it has to be 4. I'll do those to be on the safe side, but I know I'm like not really explaining this. So ignore that one for now. Folks tend to avoid that lower triangle with a few exceptions because weird things happen. I'm talking about this triangle here. The lower side of 13, column 13, 14, 15, 16, 17, below the jagged line, those are weird. What else do we want to practice? What else have we done? Any questions? Anything else you want to review? I'm going to quit trying to go on the fly here. And I'll see you guys in a few.